Continuing where we were cut off in that last video, expanding this single log into three separate logs. Again, we have multiplication in the answer part, which allows us to separate the individual logs by addition. And then our last step is to get everything on the land. So I do have this broken down into three separate logs, which is good, but I also have this exponent that is up in the clouds that we need to move down to the land. So this is where we use that weird power rule that allows us to take an exponent and move it out in front of the log. And again, it really just kind of seems like we're playing the god of math, but we're not just moving an exponent to ground level, we're moving an exponent from within the answer part of a log to ground level out in front. And again, because logs are a way of rewriting exponential form, this is why we are allowed to do this. So this would be our final answer. It is fully expanded. We have as many separate individual logs as possible, and all of our exponents have been moved to ground level. So moving on to the next problem, we have a single log, and within our answer part, we have operations of multiplication and division. So the first thing that we are going to want to do is expand this into addition and subtraction of logs. So let's go ahead and change that multiplication within the answer part into two separate logs joined by addition. So log of a squared plus log of b. And hey, just for fun, since there isn't a base explicitly written with this log, what do we know the base is? This would be a common log or log base 10. So just a little review from the last section. Now, in our next portion of the answer part, we have divided by c. So this is going to turn into the operation of subtraction. So subtract log c. Now, we've got three separate logs, but now we want to try to get everything on the land. So expand everything on the land. We're going to take that 2 and move it out in front as a coefficient of that log a. So now we have a fully expanded log expression. Now, number 3, I would put a star by this problem because this is one that is frequently missed on both homework and tests. If you look at the answer part of this log, notice that both q squared and r cubed are down in the denominator. That means I'm actually dividing p by both of those. So even though q squared and r cubed are joined by multiplication, the operation that is joining it to the other answer part is division. So when I go to separate this or expand it into three separate logs, we get log base 5 of p minus log base 5 of q squared, and then minus log base 5 of r cubed. So a lot of times students want to put a plus sign here instead of a minus, but how I like to remember that this would be a minus sign instead of a plus sign is because of the r cube's position in that division problem. So of referring back to this power property, if I move that minus sign back up with that power of 3, we know that negative exponents go to the downstairs of the fraction or switch their fraction location. So that's why this one would need a minus sign as well, because that r cubed is in the denominator. So we're going to be practicing more of that on the practice set. So finishing up this problem, our last step to expand and get everything on the land, we want to move that 2 back out in front as a coefficient from the exponent, and that 3 back out in front as a coefficient. So log base 5 of, log base 5 of p minus log base 5 of q minus 3 log base 5 of r. So folks, please make sure when you're working through the practice set that you're checking all of those little details very, very carefully, especially the signs, and remembering to put in all of those appropriate bases.